Welcome to Examrace. Here we will see the physics topic, that is Lagrangian, and it's very important topic. Okay. So Lagrangian is L is equals to T minus V, where T is kinetic energy, okay, and kinetic energy, and V is potential energy. This is different from Newtonian mechanics. Lagrangian mechanics is different from Newtonian mechanics because in Lagrangian mechanics we can able to solve the multiple system. Means example, if someone asked to solve a simple question of pendulum, we can easily solve it, or we have solved many times by using Newtonian mechanics. But here, if I attach one more pendulum, see, separately I'll tell you, if I attach one more pendulum like this is the pendulum, and here I attach one more pendulum. Now this becomes complicated situation and not able to solve it by using Newtonian mechanics. Why? Because if you see here, there are two forces. One is the tension and another one is due to this bob. Okay, another one is due to this bob. Now you can easily solve it. But when we come here, there is one bob, another bob, tension with this and with this also, okay, and simultaneously whole body is moving. So 1, 2, 3, 4 and complete motion 5 different type of forces are there, and we have to arrange them. And in Newtonian mechanics it work with the vector quantities, but in Lagrangian it work with the scalar quantities. Now we will see how. So we will deal with this problem of Lagrangian, a most famous problem and sometimes most complicated also, because not easy to solve, especially by using Newtonian mechanics. Mass m1 is given with the attached with the string of length L1 and making an angle phi1. Same case, phi2 angle is there and L2 length and mass m2. So for Lagrangian, I must write the equation L is equals to T minus V, where T is the kinetic energy. Now I'll solve this by using the coordinate system as well as the cylindrical system, because this is a two system problem. Okay, so I have to deal with those. So for this I can say that this is what x-axis and this is what y-axis. So for m1 mass, the position of bob in a coordinate system is x1, y1, and for position of bob 2, the position is x2, y2. Now what is the velocity for this one? This velocity is also related with the x1, y1. So if someone asks me to write the potential energy, that is very easy, half mv square, but here m1, for m1 velocity will be x1 square plus x1 dot square plus y1 dot square. Similarly for m2 it is x2 dot square plus y2 dot square. Okay, now what is x1 dot y1 dot x2 dot y2 dot? Before that we have to know, or we have to calculate the x1. What is x1? See, this position is x1. Now you can easily see this is 90, this is phi L1, so x1 is nothing but L1 cos phi 1. Similarly, if someone asks me to find y1, it is L1 sin phi 1. Okay. Not consider this as L1, sorry, consider this as y1. Y1. Okay. So y1 will be x1 cos phi 1, and x1 will be, because this is x, this is y axis, this is x axis. Now what about y2? What about y2? Y2 is up to here, so it is y1 plus this length, that is L2 cos phi 2. So y1 plus y1 is L1 cos phi 1 plus another one is L2 cos phi 2. Similarly, if we calculate x2, it is if x1 is this one, see, if x1 is this much, what will be the x2? Complete this one, means x1 plus x2 will be x1 plus, means x1 is L1 sin phi 1 plus L2 sin phi 2. Now we have to find x1 dot y1 dot x2 dot y2 dot. So x1 was L1 sin phi 1. From this we can easily find x1 dot, which is L1 cos phi 1 dot. Similarly, y1 was L1 cos phi 1. From here we can find y1 dot, which is equals to minus L1 sin phi 1 minus L1 sin phi 1 dot. Now what was x2? x2 was L1 sin phi 1 plus L2 sin phi 2. From here we can find x2 dot, that is L1 cos phi 1 dot plus L2 cos phi 2 dot, and y2 was L1 cos phi 1 plus L2 cos phi 2, and from here y2 dot is equals to L1 minus sin phi 1 dot plus, not plus, again minus L2 sin phi 2 dot. Okay, now just put the values in kinetic energy, that was half m x1 dot square plus y1 dot square plus half m x2 dot square plus y2 dot square. So it will be, so just simply put the values of x1 dot, y1 dot, x2 dot, y2 dot, and we will get half. If I put the value of x1 dot, y1 dot and adjust that, I will get the value half m1 L1 square phi 1 dot square plus, if I put the value of x2 y2, x2 dot y2 dot, I get half m2 L1 square phi 1 dot square plus L2 square phi 2 dot square plus 2 L1 L2 cos phi 1 minus phi 2 phi 1 dot phi 2 dot. These all are in multiplication. Okay. What about the potential energy? We know that the bob was like this, another bob like this. So height is y1 for this and y2 for this. So potential energy will be minus mg m1 g y1 minus m2 g y2. Just put the value of y1 and y2. So minus m1 g l1. What was the value of y1? We have l1 cos phi 1. And what was the value of y2? We have L2 cos phi 1 plus, L1 cos phi 1 plus L2 cos phi 2. I'm writing it again, plus L2 cos phi 2. So this is the T and V, and just put the value of T minus V and we got the Lagrangian equation. Thank you. For more course and for complete course and subscription, just visit on doorsteptutor.com. Thank you.